All right, a little review from last class, okay? So, if C is parallel to W, then which theorem leads to the conclusion that angle 3 is congruent to angle 7? Very good. Alternate interior angle theorem. Okay, if C is parallel to W, then which theorem leads to the conclusion that 5 and 8 are supplementary? Same side exterior angle theorem. If C is parallel to W, then which theorem leads to the conclusion that angle 4 is congruent to angle 8? And number 4, if C is parallel to W, then which theorem leads to the conclusion that 2 and 3 are supplementary? All right. Any questions on 1 through 4? Okay. Vertical angles are always what? Congruent. Same side, interior and exterior angles are always supplementary. Very good. Alternate interior angles are congruent. Alternate exterior angles are corresponding angles are congruent. Okay, so corresponding, alternate interior, alternate exterior angles are all congruent and vertical angles, and then the same side supplementary. So same side interior, same side exterior are both supplementary angles. Okay, turn to your vocab sheet from last time. How many spots do you have left?
6.
Okay, perfect, because we got 5 words. Okay. What we have today is just the opposite of what we did last time. So last time we had 2 pairs of parallel lines and we proved that all these different angles were congruent. Okay, or we could have proved that all of them were congruent. Okay, now we're going to have congruent angles and we're going to prove that lines are parallel. Okay, so it's just the converse of what we did last week. Okay, so our first one, corresponding angle, converse postulate. What's a postulate? Very good. Accepted without proof. Okay, if 2 lines intersected by a transversal form congruent corresponding angles, then the lines are parallel. Okay, if 2 lines intersected by a transversal form congruent corresponding angles, then the lines are parallel. So if we draw our picture, and angle 1 and angle 2, and this is line M and line N. Okay, if you were to say that angle 1 is congruent to angle 2, then M and N have to be parallel. Okay, you might also see notation like this. M is parallel to line N. Okay, those little parallel symbols, that's all. It's just like 2 backslashes. Okay, Okay, so we're just going backwards. Last time we had if two lines are parallel, corresponding angles are congruent. Now if you have corresponding angles congruent, okay, then the lines have to be parallel. Okay, next one, alternate interior angle converse theorem. So if you want to abbreviate, you can. Alt, int, angle, converse theorem. Don't abbreviate if you don't know what the abbreviations mean. Okay, but alternate interior angle converse theorem. Okay, if two lines intersected by a transversal form congruent alternate interior angles, then the lines are parallel. Okay, if we're going to use the alternate interior converse theorem, okay, what two angles would need to be congruent? Or?
4 and 5.
Very good. So if angle 3 is congruent, is congruent to angle 6, then line P is parallel to line Q. Questions so far? Okay, our next one is alternate exterior angle converse theorem. Okay, alternate exterior angle converse theorem. If two lines intersected by a transversal form congruent alternate exterior angles, then the lines are parallel. Okay, what angles would have to be congruent for alternate exterior?
1 and 8 and 4, 2 and 5.
Very good. So if angle 1 is congruent to angle 8, then line A is parallel to line B. Questions on alternate interior or alternate exterior? What does alternate refer to? Opposite sides of the transversal. And what does interior, exterior refer to?
Inside and outside of the parallel line.
Very good. Inside and outside of the parallel lines. Awesome. Okay, our last two. First one is same side interior angle converse theorem. So I'm just going to abbreviate SS. Same side interior angle converse theorem. If two lines intersected by a transversal. Form supplementary same side interior angles, then lines are parallel. Whee. Okay, what side, what angles would have to be supplementary? Or, very good. So, if angle 3, measure of angle 3 plus the measure of angle 5 equals 180, then line R is parallel to line S. Last one. Okay, our last one is same side exterior angle converse theorem. Okay, same side exterior angle. If two lines intersected by a transversal form supplementary same side exterior angles, then lines are parallel. The last drawing. Okay, what angles would need to be supplementary? Very good. Measure of angle 1 plus the measure of angle 7 equals 180. Then line C is parallel to line D. What's a theorem? Something that can be proven. So what do you think we're about to do? Proofs. Woo! Okay, but before we do them, you are going to apply some of these new terms to some problems on your notes. So look at 1 through 4. Okay, 1 through 4 with your table. I'm going to give you 2 minutes. Okay, 1 through 4. Go. It makes it easy. Rotate your paper so that you can see it as parallel lines cut by a transversal.
say that. Because line P is parallel to line R. Oh, wait. Yeah, it's not covered. Yeah, it's not. Because it's saying to justify as why it's going to go below. And then the next one is the converse.
Okay, number 1. Which theorem or postulate would you use? Angle 2 is congruent to angle 7 just to justify line P is parallel to line R. Very good. Alternate exterior converse theorem. Okay, number 2. Which theorem or postulate would use measure of angle 4, plus the measure of angle 6 equals 180 to justify that P is parallel to R? Very good. Same side, interior, angle, converse theorem. Okay, which theorem or postulate would use line P is parallel to line R to justify angle 4 is congruent to angle 5? Very good. Is this one a converse? No. Alternate interior angle theorem. Okay, last one. Which theorem or postulate would use line P is parallel to line R to justify 1 plus 7 equals 180? Okay, questions on 1 through 4. Yes?
How do you know if it's a converse or not?
So converse is when you're proving that lines are parallel. Okay, and then the other ones are once lines are already parallel, you're proving that the angles are congruent. So regular is going from parallel lines to prove that the angles are congruent. The converse is going from angles congruent or supplementary to proving that the lines are parallel. And so just like in the converse when we were writing them and how we switched it, the P's and the Q's, that's what we're doing here. All we're doing is switching it. Questions? Okay, let's look at our first proof. Okay, we've got 4 proofs to work through. Okay, number 1, given that M is parallel to P, so let's mark that. M is parallel to P, and angle 6 is congruent to angle 15. They're giving us that information. Okay, it wants us to prove that R is parallel to S. Okay, what's going in my first row? Givens. Do you want to split them up or put them together? Put them together? Okay. If we put them together, we don't need our 5th row, but it's okay. Okay, we know that our goal is to get the R is parallel to S. Okay, let's use one of our angles, 15 or 6. Okay, let's go. It doesn't matter which one you want to go to, but somebody give me something else that pertains to angle 15 or angle 6.
Angle 6 and angle 13.
Angle 6 and angle 14 are what?
I said angle 6 and angle 13 are congruent to each other because of alternative interior angles.
Angle 6 and 13. We can't say that yet because we don't know that R and S are parallel. Yes.
Angle 6 and 3.
6 and 3 are what?
Alternate interior.
Okay. How is that going to help us in our proof? I'm not saying it's not. I'm just asking. What would be your next step after that?
3 and 15.
Okay. And then 3 and 15 would be congruent because of what? Okay, but do you see how we can't say corresponding yet because we don't know that R and S are parallel? There's another way you could do it. Yeah. 15 and what? 15 and 13 are what? Because of... Okay, let's try this one. I'm just going to write them as we're saying them, and then we'll eliminate it and start over if it doesn't work. Okay? So 15 and... What'd you say, 13? Are congruent, why? Corresponding angles. Okay, somebody give me something else. Based off our first two statements, is there anything I can say or do now? I have 15 is congruent to 6, and now I have 15 is congruent to 13. What else can I say? 13 is congruent to 6. Why? So we can't go there yet because we don't know that they're parallel. Use your statements. How did we just get that 6 is congruent to 13? Transitive. Okay, so the transitive property, because it's not across operations. Keep in mind that this is just one way to do this proof. Okay, I can show you another way if you want in a second. Okay, so transitive. Okay, so basically, had I written it like this, because this is what I have so far. Notice how these can just drop off that middleman term. Okay, so transitive, now we have angle 6 is congruent to angle 13. Okay, what do I have now?
Because 6 and 13 are congruent, R and S should be parallel.
R and S would be parallel because of?
Interior, alternative interior, converse.
Very good. Alternate interior angle converse theorem. Okay, so like I said, this was just one way. Okay, you could have said that originally when I did this, I said 15 and 14 are same side interior angles. Okay, so then if 15 is congruent to 6, then 6 and 14 also have to be same side interior angles, which would make those parallel because of same side interior angle converse. Okay, so there's all different ways to do proofs. Okay, but a lot of us made the mistake that I figured we would, which is great learning point to make. Don't assume, it's not you're assuming, but don't say alternate interior angles, corresponding angles, all those good terms if we don't know those lines are parallel yet. Okay, so don't make that mistake. Okay, you have to prove that those lines are parallel before you can use any of those theorems. Got it? Okay, let's try another one. Okay, the next one doesn't necessarily have to do with angles, but it is an important one. Hopefully some of you guys have seen this one and done it on homework already. Anybody recognize this one? Okay, good. Okay, RT is congruent to SU. Prove RS is equal to TU. Okay, what's going in number 1? Very good, and why is that? Given. Okay, when we share a piece, what do we have to do? ST equals ST because of? Very good. Okay, if what you're trying to prove shares a piece, whether it's a segment or an angle, make sure you always use that reflexive property. Okay, somebody give me something else. What?
RS plus ST equals RT.
Very good. RS plus ST equals RT, and why is that? Very good. Segment addition postulate. Somebody give me something else. going along those same terms as number 3, Miranda.
ST plus TU equals SU.
Very good. ST plus TU equals SU. What's the reason?
The segment addition.
Very good. Segment addition postulate. Okay, somebody give me something else. RS plus ST equals ST plus TU. Why is that? Substitution. You can tell that some of you guys did this one on your homework. It's awesome. Substitution. Okay, so all we did, we know that RT equals SU. Okay, so now we took what RT is and put it in place for RT. What SU is, put it in place of SU, and that's how we have this substitution right here. And what would be our last step? RS equals TU, and why is that? ESPO. Nice. That was awesome. Great job, y'all. Questions on that one? Flew through that one. That was great. Okay. Next one. Ooh, this one's a long one. Okay. What's going in reason 1 and statement 1, sorry, given? M is the midpoint of AB, and I'm not going to be able to write the rest, but you guys can. And N is the midpoint of CD, and AB equals CD. Okay, using that first piece of information, okay, M is the midpoint and N is the midpoint. What do we know? AM is congruent to NB. What else? Very good. And I'm just going to put those together because they have the same explanation. And what's that explanation? Definition of midpoint. If two things are congruent, what does that mean? They're equal. So now we can get rid of our congruent symbol. We know that AM equals MB, CN equals MD. If you forgot this step, I wouldn't count it wrong. Okay, we also know that AB is the length of CD. Okay, we know all those pieces are congruent. Okay, somebody give me something that might help us.
AM is congruent to ND or equal to ND.
AM is equal to ND. How would you know that?
Because the AB and CD is
We can't use that yet. Okay. AM plus what? Very good. AM plus MB equals AB. What else following that same pattern? Very good. CN plus ND equals CD. And why is this? Very good. Segment addition postulate. Yes. Oh, thanks. Whoops. Okay, so we have segment addition postulate. Okay, where can I go now? We know that AM is equal to CN. We also know that AM is equal to MB. CN is congruent to ND. Yes. But AM plus what? AM plus ND is equal to, did you say ND plus CN? How do you know that? Because of substitution. So what did you substitute? Or where did you substitute, better yet?
Step 4.
In 4, A and given A, B, and C equal each other. In 4,
Oh, okay, gotcha. I'm following now. How did we get ND here, though?
That's supposed to be
That's supposed to be MB. Did I write it wrong? Okay, MB. Okay, awesome. Now I'm following. They could have picked easier letters that don't all sound the same. Okay, so, but this is by substitution. Okay, I'm with you guys. Where could I go now? AB equals CD. But that's in the given. So where are we putting that? That's what we just substituted in for. AM equals ND. How are you getting that? Okay, what if I help you guys by saying AM plus AM equals CN plus CN? How did I get that? So do you see here how we have AM equals MB? So I just put AM in this place. CN equals ND, so I just put CN in that place. Yeah, but I mean, this isn't necessarily wrong, but it could have been done in less steps. Okay, so this would be what reason? Substitution. Okay, now what? If we add these, what do we get? 2AM equals 2CN, which is what? APO. And then what would the last step be? Depot. If I divide both sides by 2, I get AM equals CN, and that's by depot. Where would you want to do SPO? So do you know, like, so if I would have done SPO, they have to be the exact same thing to subtract from both sides. Yes. I put M instead of, yeah, I keep doing that. Hey, there should be an N. Thanks. Okay, so that was a nice long one. If you think you can do it in fewer steps, I challenge you to, and then let me check it so I can see it, if you can do it in fewer steps. Okay, last one then. Turn it over. Given angle 2 is congruent to angle 7 and line K is a transversal, prove M is parallel to N. Okay, so we know that 2 is congruent to 7 and K is a transversal. Okay, so I'm going to write that in line 1. The reason being given. Okay, somebody give me something. Using those angles that are congruent. Somebody give me something. Using angle 2, let's say, what do we know? 2 is congruent to 4y. Okay, so that's kind of what I was talking about last time. You guys are always already trying to use theorems when we don't know they're parallel yet. So we can't use corresponding, alternate interior, alternate exterior, any of those until they're parallel. Yes? Angle 5 is congruent to angle 2. How? Vertical angles. Very good. Okay, if you wrote definition of vertical angles are congruent, whatever you want to write. Okay, give me something else. Angle 5 is then congruent to angle 7. Why? Transitive. Okay, so now we have 5 is congruent to 7. What else? Pardon? What could we have used right away? A converse theorem. Okay, so what could I have used right away? We had 2 and 7, so what should we have used? Alternate interior angle converse. Okay, so although that we've done all this, that's great. As soon as they gave you that 2 and 7 were congruent, these are alternate interior angles. So you could have used alternate interior converse theorem, and then those lines have to be parallel. Okay, so I was going to see how far you guys would keep going, which is fine. Okay, after you got 5 and 7 congruent, which is the transitive property, then you could have said 2 and 7 are corresponding angles, are in corresponding position because of their definition, because they are congruent. And then you would have used the corresponding angles converse postulate, which is fine as well. Okay, so I'm just going to continue working this in case you want another example. But you could have said angle 5 and angle 7 are corresponding. And there's definition of corresponding angles. And then you would have said M is parallel to N because of the corresponding angle converse postulate. So whether you jump straight to the alternate interior converse or you went all the way down to corresponding angle, or if you found another way, great. Okay, they're all right. Okay, just some take more steps than others. Questions? Okay, then the remainder of the class, I'm going to hand out your homework in a second. You can work on your homework or you can study for your test. Okay, and by study I mean work on that test review if you haven't done so already. Okay, the test review key will be posted online sometime this evening if it hasn't been posted already. So that way you guys can check your answers and make sure you're studying the appropriate things. There will be proofs, okay, and there will also be constructions on your test. I can't remember how many constructions we put on the review, but you're going to want to know how to construct a perpendicular line. You're going to want to know how to construct parallel lines, or a median, or an altitude, or whatever. Okay, all those constructions we did on 1.6, 1.7, I believe almost 2 weeks ago, are fair game for this test. Okay? Just because they're not on the review doesn't mean they're not going to be on the test. Okay? A review is just a courtesy of extra problems. Okay? You should look at all of your notes, all of your proofs. The proof that's on the test is not foreign. It's not going to be the first time you ever see it. It's going to be something that we've already done. So make sure you're utilizing this time wisely. Got it? Okay, I'm coming around with your homework.